All right, we are going to come up with a set of classes that handle this scenario in sales rep. All right. First of all, what we're going to say is that a sales rep, just your ordinary average sales rep, makes $2,000 per pay period. I don't know what this would be, every 2 weeks, let's say. I don't know, every month. No, a month, that wouldn't be too much. Every 2 weeks, let's say, and gets paid 10% commission. A junior sales rep makes $1,500 per month and gets paid 7.5% commission. And finally, a senior sales rep makes $2,500 a month and gets paid 12.5% for $0 to $10,000 sales, and gets 15% for anything above 10,000. So I created classes for these. And let's open them up here. I also created a test class. It's already open. Now, if you're going to think of these in terms of inheritance, it would make sense to say that a sales rep is the base class. It is the parent class. It is the super class. And the other two are kinds of salesmen, sales reps. So therefore, it would make sense to say that junior sales rep extends sales rep. And senior sales rep also extends sales rep. It would make sense to say that because a junior sales rep is a kind of sales rep. Senior sales rep is a kind of sales rep. It wouldn't make sense to say that a senior sales rep is a kind of junior sales rep. That's not true. All right. But it makes more sense to do in this way. Therefore, if you notice, our sales rep is the default class or the base class, the super class, and junior and senior sales rep both inherit from that. Now, let's look at the attributes we have for a sales rep. We have a employee ID, string for name, a double for sales amount. These are protected, which means that stuff inside the class or any class that inherits from this class can access those properties. I have my constructor for sales rep that takes 3 arguments, one for employee ID, one for the name, and one for the sales amount, and calls the respective set methods. For each of these attributes, I have a set and get method. The set method allows us to assign a value to that attribute. The get method allows us to retrieve that attribute. Now notice that in the constructor, I don't simply say employee ID equals arg employee ID. Now, it might not be obvious why I don't do that right now, but the reason I don't do that is because later on, we're going to have validation code. All right, later on, we're going to have validation code. We're going to put that validation in the set method. And if we set that attribute directly, without going through the set method, we would have to duplicate the validation method up here, the validation code. And whenever you have code in two places, that's not good. Our whole purpose of devising these classes and methods and all that is to eliminate duplicate code. Remember the slogan DRY, dry. Do not repeat yourself. All right. Wherever we have the same code in two places, chances are that it could be streamlined to have that code only be in one place. This is the reason, by the way, that we don't make these public, right? If we make these public, then anyone in any class could set the value of this attribute and circumvent any validation method that we would have for the ID, right? And the same applies for the other attributes as well. So instead, everything is going to go through the set method. Anywhere that we try to set that attribute, we're going to force to use that method. That's the only way that you can set the value of that attribute. So all of our variables in our constructor, all our arguments, we're calling the appropriate set method. So there's our sets that set the method to the attribute. There's our gets, which return the value for the attribute. We then have a couple of gets here that are get commission, get base salary, get total salary, and get to and finally to string. Sometimes when you talk later on, if you take further Java classes and get into Java Bean development, we would call something like commission, base salary, and total salary a read-only attribute. All right? Because we can't set that attribute. We can only access it. And we access it by calling the method. And for a regular old sales rep, the commission is 10% of the sales amount. The base salary is simply $2,000. And finally, total salary is the sum of the base salary plus the commission. I also have a toString method. And the purpose of the toString method is allow us, it's a good practice to sort of define that on every object. It's a way to display something that tells you what this object represents. So in this case, I'm displaying the word sales rep, colon, and I'm concatenating the name of the person after it. I could display any number of things. I could display their employee ID and name if I wanted to. Anything that is sort of a string description of what the object contains is a good candidate to have in the toString method. Now, let's think about these one at a time, and let's see if we need to define these on the subclasses or not, knowing that this is our rule. A sales rep has this, a junior sales rep has this plus that, a senior sales rep has this plus these two things. Do we need to redefine these variables in the subclasses? The answer is no. It's defined on the superclass, that's good enough. So I don't have to put employee ID, name, and sales amount in the subclasses. Now, if there was something additional that a junior sales rep had that an ordinary sales rep didn't have, then you could define an attribute in the junior sales rep class. But for these particular attributes, no, all sales rep have these attributes. So they're defined on the sales rep class, that's enough. So we don't have to define these under sales, junior sales rep or senior sales rep. We'll talk a little later on about what if there was an extra field. Maybe junior sales reps have a mentor or something that supervises them or something like that, that a regular sales rep and a senior sales rep wouldn't have. Do we need to put the constructor in the subclasses? And the answer is yes. We need to include a constructor in the superclass, in the subclasses rather, because a subclass does not inherit from the superclass the constructors. So this is a constructor for the sales rep class. Just because we inherit the junior sales rep class or the senior sales rep class from a sales rep, we do not get the constructor. Therefore, we're going to have our own constructor. And again, since these don't have any extra attributes, the constructors can match up with the constructor in the sales rep. So in other words, for our junior sales rep, it's the same three arguments: employee ID, name, and sales amount. And for the senior sales rep, it's the same three. What happens if we don't define a constructor for the junior sales rep? Then a no argument constructor would be generated by the compiler for a junior sales rep, and that would cause a mess, because the generated constructor would not call the superclass's constructor properly, and therefore would get an error. We'll try that in a few minutes here, because I want to show you some of the things that can go wrong in addition to showing you code that is correct. Do I need to identify a set ID, set name, and set sales amount? No. I declared those in the superclass. There is no need for me to declare those in a subclass. All right. If there were extra attributes on the junior sales rep class or the senior sales rep class that were not in the sales rep class, then I would have to declare sets and gets for those. But I don't have to here. In fact, again, we wouldn't want to declare those here, because eventually this is going to have the validation code to make sure that the set ID method is correct. We don't need any of the sets. We don't need any of the gets. Do we need to override? Do we need to have this get commission function? The answer to that is yes. Why do we need it? Because the rules for calculating commission are different for junior sales reps and senior sales reps. For a regular old sales rep, they get 10% commission. For a junior sales rep, they get 7.5. And for a senior sales rep, they get 12.5 up to $10,000 and 15% for if they've sold more than, for the amount is over $10,000. So in other words, if this guy sold this amount, their commission would be 1,250 if they sold 10,000. If they sold 12,000, it would be 1,250 plus 15% of 2,000, which would be 600. That would be 185 total commission. But the bottom line for our purposes here, we just need to override it because there's a different way of calculating the commission. So we have get commission and we have get commission. Way the get commission function is written is we take 12.5 of the whole sales amount, and of the amount greater than 10,000, we take an additional 2.5%. So for the amounts over 15,000, we get actually 15%, the original 12.5 plus the additional 2.5. Get total salary. Do we need to override that? Here's the interesting thing. No, we don't. All right. No matter the kind of sales rep, their total salary is going to be their base salary plus their commission. I think I forgot to mention get base salary. We do need to override that because the base salary is different for each type of sales rep. But calculate total salary, we don't need to override. Because in all cases, we're going to take whatever their base salary is, no matter what method gets called, the appropriate one will get called, and their base salary will be whatever amount is appropriate for that category of sales rep. And then we're going to add the commission calculation value to that. And that's their total salary. To string. Are we going to override that? We actually are, because for a junior sales rep, we're going to say junior sales rep and their name. For senior sales rep, we're going to say senior sales rep and the name. Now, I've added an extra method on a senior sales rep, just because at some point I want to talk about what happens when there's a method in the subclass that's not available in the superclass. So let's compile this, make sure it runs correctly, look at the results, and above all, make sure the results are correct. So get over here. We compile. It compiled cleanly. We run it. And sales rep Mike, their base salary is $2,000. Is that correct? Yes, it is. Their commission is $500. Is that correct? Well, I don't know. We didn't look to see what their sales were. I probably should add to my unit test, probably should output what their sales are. Get sales amount. I'm going to add that to the other two as well, because I'll bet I forgot it there too. This way I can look at the output and I can make sure that the output equals the output equals what it should be. Now I'm going to go save this, file it. It says base. You may not think it's a big deal. Oh, you will remember that the second base should be the sales amount, but go back and change these things. Use variable names that make sense. Use output that makes sense so that you or anyone else can look at the output and see if it does in fact make sense. Okay, first person, base is sales rep. Base salary is $2,000. Is that correct? Yes, it is. Their sales is $5,000, so their commission is 10% of that. Is that correct? Yes, it is. Their total amount sold is $2,500, or their total salary is the $2,000 plus the $500. That gives us $2,500. Junior sales rep, base salary is $1,500. Is that correct? Yes, it is. Their sales is $4,000. Their commission is $300. Is that correct? I don't trust myself to do math in my head, so I'm going to pull out a calculator. And this is what you should do when you're testing your code. It's because your program spit it out that their commission is $300. Don't trust that. Make sure the value is correct. And yes, $300 is correct. Total salary is the base plus the commission, or $1,800. Sales rep, Mike, $2,500 is their base salary. Correct. Their sales is $8,000. The commission is $1,000. Is that correct? Well, they should be getting 12.5% up to $10,000. And let's make sure that that's correct. 8,000 times 0.125 equals 1,000. So they're correct. Let's forget about this down here. Okay, we'll ignore that for now. Now, is this enough to test to make sure that our code works? Given that these are all the possible scenarios, am I missing a test case, or is there something else I need to test, or did I test enough? I tested junior, senior, and regular sales rep. Okay. Am I missing something? I should test. Were you going to say something? Okay.
I was thinking, but
Okay. I should test someone that is a senior sales rep that makes more than $10,000 worth of sales. Because if I look at my code, we covered this and this. We covered this and this. We covered this, but we did not cover if this if statement works correct. All right. Therefore, we should have at least one more test case. And so I'm going to go into my unit test. And I'm going to create another test case. It doesn't take that long to create another test case, right? Copy and paste, and I'll make this to be, say they sold $18,000 worth of merchandise. All right, let's test to make sure that that is correct. According to this, their commission is $2,400 plus the $2,500, that is $4,950. So the addition is correct. Is their commission right? Well, what do we have to do? We have to go back to our specifications and say they sold. Make this bigger so I can draw on it. They sold $18,000 worth of stuff. First 10,000, they get 10% of. That's 1,000. The amount over 10,000. Oh no, I lied. They get 12.5% of that. So that would be $1,250. And for the amount over 10,000, they get 15%. So what's 8,000 times 15? That is 1,200. That is $2,450 commission. And yay, that's correct. So we did the calculation correct. See the idea though? We're going to be very rigorous in making sure our program works. We're not just going to run a couple sales reps and consider that we've tested it thoroughly. Really, if I wanted to test this, I would test something right on the border of $10,000, like maybe right at $10,000. And I would test just over $10,000. $10,001. All right. So for that extra dollar sales that that person gets, they should get paid 15 cents more than this person did. Than this person did, and sure enough, they do. Got to put the blank line here. You notice how easy it is for the output to be read. And I'm not going to pick on anyone individually, but sometimes I get like just numbers printed out and I'm supposed to figure out what they mean. You know, clearly label your output. That's for both for your benefit and for mine, so that you can look at it and make sure, hey, this worked. So you can do the calculations by hand and to see exactly what if these values are the values that they're supposed to be. So now I would say, yeah, I probably have tested this enough to make sure that it is reasonably correct. Once I tested one of these, and because there's a if statement in the commission calculation, one that made less than 10,000 or less, one that made more than 10,000. All right. Now there's one thing I wanted to show you. We talked about polymorphism. Let's look at this sales rep here. And I'm going to say sales rep L equals new sales rep. I'm going to delete all the other sales reps for now. I wouldn't suggest that you do something like this, right? Because even if you add something, like let's say you did lab 3 and lab 4 builds on top of it, or lab 5 builds on top of that, still keep the test that you had before and add new tests in it. But because I'm lecturing up here and I want to demonstrate something, we're only going to look at this one sales rep. I'm going to comment these lines of codes out. So pretend you don't see them. I have a function here called senior sales rep stuff. That is meant to represent a function that exists only on senior sales reps, but on none of the other sales reps. Now, if I create my senior sales rep variable called L and populate it with a new senior sales rep, let's see what happens. And then once it happens, let's explain why it happened that way. Oh, it didn't work because that shouldn't be S, that should be L. It displays senior sales rep stuff. Why does it do that? Well, because I declared a variable of type senior sales rep. That means that that variable can do anything that a senior sales rep can do. I create my new senior sales rep, and I call the constructor. Since this is a senior sales rep variable, I can call any methods on the senior sales rep class. So I can call senior sales rep stuff, which I do in a unit test, and the value gets outputted. All right, everything nice. Now, if I do this, sales rep L equals new senior sales rep, this variable L, now, as far as the compiler is concerned, can only do the things that a regular sales rep can do. I can do this. I can put a senior sales rep object into a sales rep variable because the senior sales rep is a sales rep. So I can put that in there. All right. I could put a senior sales rep in a variable that's meant for sales reps. However, I can only call the functions that are defined on sales reps. So now when I try to compile this, nothing happens because I forgot to save it. When I compile it, it tells me it doesn't know what senior sales rep stuff is. I might say, what do you mean it doesn't know what senior sales rep stuff is? I create a senior sales rep. So why can't I call the senior sales rep stuff function? It's declared on senior sales rep. I can't do it because I declared the variable that it's in as simply a sales rep. Therefore, it cannot call any methods that exist on the senior sales rep, only the methods on the sales rep. Unless I do this. This will tell me, this sales rep that I have stored in L, is that really a super sales rep? Or not super, senior sales rep? If it is, then I can convert this L into a senior sales rep variable, and then I can output the value of that senior sales rep variable. That's known as casting. Sure, I've saved everything. Get rid of that. And I can call the senior sales rep stuff on the variable that got converted from the plain old sales rep. Now notice it still calls the right methods. The senior sales rep methods for calculating sales and calculating the base salary and commission and all that. Remember, this side defines what methods you can call. So if it's defined as a sales rep on the left side, I can only call sales rep type functions. This side, the side with the new, determines what version of the function it's going to get. So it's going to get the version of the function on senior sales rep. Finally, this is a test where we can check to see, is that actually a type of this variable? Is this variable actually an instance of a senior sales rep? If so, then I can do the conversion and I'm off to the races. Any questions about any of that? I have a checklist here I'm going to look at to see if there's anything else I want to talk about in our last few minutes here. Oh, I do. I want to go over Java dates. I have this fun, there's a page that talks about Java dates that you can read through. But I made this fun with dates class. That we want to spend a little bit of time taking a look at. It's one of your labs, I forget exactly which one deals with dates. Let me compile it. And let me run it. And it shows me a bunch of output where I did not take my own advice and label the output clearly. Let's look inside of this function or this object and class. And first of all, we need to import these things. Import simply allows us to use the short version of the class name, which is just this part, when referring to this. So we're going to use local dates, local times, local date times, month, and temporal chrono unit. All right, we just have a main method in this function. I create a local date by doing this. Notice I'm not using a new, I'm not creating it using a constructor, but instead I say local date.now. That's another way to make a new object. Is this has a method, this has a static method called now that outputs a new local date object. So if I say local date now, my date object is going to have today's date in it. And sure enough, it does. If I say local date of 2016-7/4, the date is 2016-7/4. I can also define the month 2016 month.July, and again, all of the month names would work here for, and that'll give me a second date with the month of July 4th, 2016. Now here's where it gets a little interesting. I ask if date 1 equals date 2. Now you might think date 1 contains 7/4/2016 and date 2 contains 7/4/2016. You might think that those would be equal. Those are not equal, however, because remember, when you are comparing objects, you're comparing to see if the pointers are pointing to the same object. And in this case, local date is pointing, date 2 is pointing to one local date object, date 3 is pointing to a different local date object. So these are different objects, so it tells me that the dates are not equal. It's telling me that it's not the same date object, date 2 and date 3. Here, however, I use the equals function to see if date 2 equals date 3, and that one tells me that it is, in fact, equal. Those two dates are equal. Plus days. So I can go and I can say, what is the date when I take date 1, which is today, and add 28 days to it? And that date is correctly stated 2023, March 27th. I can ask if one date is after another date. In this case, date 4 is 28 days past the current date. Is it after the current date? Yes, it is. I could go backwards. I think there's a subtract time or a minus days, subtract days or minus days that will allow you to go backwards in time if you need to. You can get that from the local dates reference that I posted a link to. This will tell me the difference between 2 days. What's the difference between date 4 and date 1? Date 1 and date 4? 28 days. How many days until date 4? 28 days. I don't know why I have this duplicated, but I do. I display that it's 28 days. These are all things that you can use in your assignment, because you do have an assignment with the dates, and also there is documentation about the local date class that you can use. So I know dates are confusing, but take a look at this Fun with Dates class to see how you can do some very typical things with dates. And again, if you have any questions at all, let me know. All right, that's all I had today. I will either see you in lab or see you next week.